Hey Trevor.
Hey Josh, how you doing, bud?
Good. How are you doing?
Not too bad. How's the weather?
It's nice. Yeah, we're actually a little above normal.
Oh, really?
Yeah, we should be in
What?
the high 70s and we're in the high 80s.
That's nice.
Yeah.
Haven't had that since first of September, probably.
Okay. Yeah, it never really gets very cold here. I mean, in winter, it gets a little cold, but nothing like you guys.
Yeah, the crazy thing, it's been above normal here for this time of year.
Hi,
Hey Sarah, how's it going?
you guys.
So normally it's like
Hey,
42
Sarah.
for the hour, and it's been in the 50s, so it's been quite warm. I
I
mean,
know today was really nice.
warm for here. That's freezing weather for Josh.
Yeah.
Yes, we're above normal. We're in the 80s instead of the 70s.
And we're in the 50s.
Yeah, my husband hates
Yeah,
the heat, but I love it.
what's that?
We're on audition. I hated it.
Yeah, I don't know. I like 60.
Everybody's putting me to lose me. I think the heaviest point of my mission.
Because of all the good cooking.
Did you guys see what she put on the
Yes, I'm just answering to
Okay.
this one we bought down in Utah, and the other one we had open. Sorry, we're just finishing up dinner, so.
Oh, no worries. No worries.
Okay.
So the
Questions.
math tutor,
Yeah, the
she
quizzes just get longer and longer.
Dude.
so the math tutor she got with me tonight, or she emailed me back and said she can't do Thursday. So I told her like whatever we decide for next week or the week after. So
Okay.
whatever.
And now next week, though, will we just be having one meeting since it's Thanksgiving?
It's just the review for this next exam.
Sorry,
Okay.
Trevor, you were kind of cutting in. What did the TA say?
Oh, sorry, the connection's not too good. The TA said she can't meet this Thursday,
Okay.
but that we'll try to figure out another time, like next week or the week after, something like that.
Like
And
the semester's almost over and she's just now
yeah, I
contacting
know.
us.
I know.
I found that a little weird.
Yeah, you know what I mean? Because it shouldn't be that hard because there's
Just
only
here
like
to monitor us and help us. Yeah.
there's only like 6 or 7 groups, so it shouldn't have been that hard.
And
She's probably just
And-
coming in because she's watched all your videos.
Yeah,
and keeps
yeah.
hearing this complaint.
and it sounds like too that she's supposed to be meeting with like 2 groups a week. And it's
Yeah.
like
That didn't happen.
I don't even think there's that many groups to be meeting with twice a week.
No. I think there's like maybe 7 groups,
Hmm
8 groups, because a lot of kids drop the class.
I know. So no wonder.
So I don't know. So the quiz, what is there? 20 questions? Yeah. But it's really not that hard material, though. It's actually pretty quite easy what we're learning right now.
That's true if it's based on our reading.
Yeah. Like it's pretty abstract. So what does this mean? I don't know. I have no clue. Why don't I go search the web for a few hours and get back with you?
Okay. Should we start on question 3 then?
Yeah, let's do it.
Yeah.
Okay.
Use the data in table 1 to find P1. Alrighty.
So P1 is the proportion of females in the population that can taste the PTC, right?
So of candidates, so would that be female as the female would be X1, then N would be 72.
You can taste. Oh, let P1 be the proportion of females in the population who can taste, and then P2 be the males that can taste.
So there's like an X1, N1, and X2 and N2. Is the N1 like the female? The no?
Yeah. Or no. So it just says the yes. So I think the X's would be our yes, and the N's would be the total.
Total, okay. So it's asking those that can taste it, right? Okay.
Yeah. Yes.
So X would be 52 out of 70. All right. Just put that in there. 52. 70 for N1. And then males is 42 and 59.
Mm-hmm.
And it's asking
For the
difference or
PCAT?
yeah. Let P1 be the proportion of females who can taste the PTC and P2 proportion of who can taste PTC. Okay.
So did you just get 0.743?
No. For P1, I got 0.403.
Is for your type of test, is P1 greater or is P1 less than?
Oh, I just had type of test not equal to.
Is it? I'm just,
I don't know.
let's see.
Okay, so to find the P, you just divide the X by the N. The total number was 129. So wouldn't I just divide 52 by 129?
Well, it only wants us to look for the yeses, so you would have to take out the no's from that total of 129.
Are you sure? Because it says from the population. Is the population only the yeses? Wouldn't it include the no's also? Isn't the population all of them that were asked?
Yeah, so it would be like, so for the females, since we're just focusing on yeses, it would be like the 52 out of the 70.
It says the proportion of the population who can taste the PTC.
Oh, I see what you're saying.
And then the males are those who can taste the PTC. So
Yeah.
I think I put it in Excel, and well, we can even do this on hand too, if it was that's the case.
Yeah. Use a very long formula.
Oh yeah, I don't want to do the formula. Yeah, yeah, so it's just asking if it's different. So I got 0.743. It's not asking if one's greater than the other.
Yeah, so, and I wonder, let me see if it makes a difference if you change.
It should, I think. It'll make a difference. I guess it doesn't, does it? No.
No,
It's
no,
0.7,
it's,
but what will change is the p-value.
yeah, the p-value will change.
Did you get that, Josh?
Yes.
Yep. Okay.
Perfect.
Should we go with 0.743 then?
0.753
So then p hat 2,
would be 0.712.
yeah, that's what I got, 0.712. Okay. So I got the last one on 5. Or is it the first one?
Yeah, because the only difference between the first and last would be those p hats.
Yeah, the first one's asking me for the proportion, but this one's just the p hat, the sample, I guess you might say.
So we think it's the fourth one. And the alternative is the p hats.
I think so.
Such a guessing game.
Yeah, I'm just trying to look at our preparation thingy.
Yeah, I'm running through the preparation, and all I see is the p hat when it says for the null hypothesis, trying to test it.
Hmm.
I think
Yeah,
so.
that homework might not help too much.
I think it is, but
Yeah, I'm just trying to find, because I know there was that example in our reading.
oh yeah.
And so you guys think it's the last one for question 5?
I guess we get it wrong. It's either the first or the last, that's for sure.
Yeah, I yeah, I don't know. But I almost wonder if,
The first one?
yeah, because if the last one has the p hats,
Yeah, yeah.
wouldn't shouldn't the alternative and the null both have the same symbols?
Yeah, you're probably right. Yeah, I would. Okay.
Yeah, I just wrong tube.
Oh boy. Yeah, you're probably right. I think it would be the first. I didn't see that. You gotta have consistency there.
But I wonder if that was for, because what is this for? Just the hypotheses?
Yeah, it's just asking is P1 equal to P2 is the null, and then the alternative is P1 not equal to 2.
Okay. Yeah, I think it would be the first one. And then the last one, maybe that would be referring, well, I don't even know when you would use that last one.
I don't know either.
Okay, so we're all good with the first bullet point then?
Yeah.
Yeah. Sounds good.
Excuse me. Alrighty.
Let's go on to number 6. All right. Put a 95% interval.
So now is it we just take our P1 and subtract P2?
Put a 95% interval for P1 minus P2. Input your answers for the point estimate margin of error. Confidence interval. Is that what we just do? Just take the lower? We'll definitely get a negative though. Is that how you do it?
Yeah, well, that's what it looks like, just P1 minus P2.
Okay.
But I'm not 100% sure.
So for number 6, are you putting in the information into the Excel program, Brian?
All I'm doing, I don't even know if it's right though, but I'm just taking where it says the confidence interval on your called the categorical data analysis Excel thingy, and I'm just taking the negative 0.123 subtract 0.185.
Okay, so this one, the question 6 is asking what's the point estimate for this 95% confidence interval.
Mm-hmm.
And question 7 says what is the margin of error?
Yeah, and then I guess the question would be like, what formula would we even use for error?
Like what we did in previous questions was take the higher minus the lower divided by 2, but I don't know if that'll work in this situation. When sigma's unknown.
Oh. Yeah, because
they throw in random questions that isn't part of the lesson.
I know it's like, let me just focus on the lesson and that's it.
Yeah, I mean, goodness.
Well, I wonder if it's two-tailed. So if that were the case, I mean, maybe we would divide it. Sorry, what was that, Josh?
It is two-tailed, isn't it? Because it's the equals.
It is two-tailed.
Yeah. So I wonder if we would then is it the p-value we would divide by 2?
No. Confidence interval, you take the upward bound minus the lower bound. Is that right? Yeah, upper bound minus lower bound, then divide by 2. I think.
And that would give us the margin of error?
I think so.
Oh, that's right. Okay.
I think
So
that's
did you guys do 6 then? What is the point estimate?
I'm not sure. Is it P1 minus P2?
It says that the right above question 6.
Yeah.
P1 minus P2, but then it's like, yeah, would we do the negative number minus the positive or the positive minus the negative?
Man. So you have negative 123 minus 0.185 equals negative 0.308 is what I got if you take this P1 minus P2.
Yeah, that's what I got too. I'm just plugging the other one, see what I get.
Yeah, I don't even know if that's how you do it though, because I never saw this anywhere in the lesson.
I know, and I think too, wouldn't it have to be for our confidence interval?
Yeah, imagine so. So,
I'm just trying to remember. You just have to decipher what the point estimator is. Is that just the x? Or is that the proportion? If I remember correctly, the point estimator is 1 point.
Are you referring to like it's one number when you say 1 point?
Yeah.
Yeah, you're right there. And I'm just wondering, Yeah, I don't remember them ever talking about point estimators in this chapter.
I'm sure they didn't.
Because I remember, you know, they showed us how to find the upper and lower. But then it's like, when did they ask, you know, for us to find a point estimator?
Never.
Yeah, exactly. That's our problem.
5% comes in as equals 1.16. You have one. Okay. What is the point estimate for 95%? Point estimate.
Yeah, I think it's got to be either the negative 0.308 or the 0.308, but I don't know which one.
Okay, notice that 0 is not a constant, so 0 is not positively 4 by 4 p1 minus p2. Okay, I think I found something here. All right, let's see. It is reasonable to conclude that the proportion contains. Yeah, I guess it'd be 0.38. I don't. So it's P1 minus P2.
So should we just go with the negative 0.308 then?
I guess.
How did you
And then
do that?
So I just went to the little spreadsheet and just took my negative 0.123 subtract 0.185, where it says I can't even talk, confidence interval for P1 minus P2.
Yeah, that's the lower and the upper bounds. You
Mhm.
subtract them and you divide by 2. That gives you the M.
Yeah, but I think what we're trying to figure out.
Let's see.
Okay, maybe we're overthinking it. Maybe the point estimator, I know, it's 1 point. It's like the mean or whatever number. And if it's the interval for P1 minus P2, maybe we just need a minus P1 and P2, and that's the answer.
Yeah.
So just
So
find,
maybe
Sorry?
just leave it at negative 0.308 then.
well, no,
Yeah.
we need to find what value is P1 and what value is P2, and then just subtract them.
Mm-hmm.
Yeah. I think so.
Wouldn't P1 just be the 52?
That's a good question.
Okay, so
I don't know. I'm confused.
P1 minus P2. Input your answers for the point estimate. Margin of error, lower bound, upper bound. Okay.
Now, for point estimators, can you have decimal point numbers? Yeah.
Oh, yeah, you can.
Okay.
The only time I guess you don't have a decimal is when you're trying to find n, like a sample number. Then you have to round up to full number.
Okay.
But I did the margin of error, the upper minus the lower, divided by 2, and I got 0.154.
0.154, that's what I got too.
And I mean, it's what makes the most sense to me because there's nothing else. No. The lower bound, negative 0.123.
And oh, sorry for the number 7. Did you get 0.154?
Yeah, that's what I got.
Okay, so 8 would be negative 0.123. And 0.185 would be 9.
For 10, I got A, failed to reject the null hypothesis.
For number 10, you said you got A?
Yeah,
That's what I got, right? Because the P is bigger than the level of significance.
yeah, it's 0.693.
Mm,
Did you get
mhm.
that, Sarah?
Yeah, I did.
All right. So which of the following statements best describes the outcome of the study? There's Is it D? Yes.
Yeah, that's what I think.
Because it's asking if it was different. Those who can taste.
Because since we failed to reject it, it's insufficient evidence that it's
Yep.
different.
Yeah. Yeah, I'd agree with that 4th one too.
Okay. Alrighty. More data. Mortality rates of and data of emission from study.
With this one, don't we have to use all those greater than or equal to 10 for the requirements?
And for the requirements for like to see if it's satisfied.
Uh-huh.
Yeah. Yeah. Well. Yeah.
Okay.
See, we'll have to do that.
And so we want to
so
know.
Yeah.
So P1 will be the proportion of patients who had a heart attack.
You had a heart attack, like from group 1, and died, right?
Oh yeah, and we're admitted on
died on a
Wednesday.
weekday.
Okay, so weekday is group
Yeah.
1 or X1 and N1, so that's 16,000 and 118,000. The second one's 6,000, whatever, and 42,000. Okay.
Um,
Did you guys get positives on the test, or did you get a negative?
are you talking about on our table?
Yeah, for, I mean, for the requirements, like putting the 118,000 times 1 on it.
Oh, there's my, okay. Yeah, I got all positives.
All positive, okay.
I thought for some reason I had to do that all by hand, so you stopped me before I started putting them all in.
Yeah, yeah, they're all second sample, I guess. I guess it's all above 10, right? So we're good to go.
Hmm.
Yeah, I was in it by hand, and I guess I checked it. Did you get positives, Josh? Josh left us.
Oh, did he? Did he? Uh-oh.
I don't know. Let me check.
Oh, did you put? Awesome. This isn't good. I'll try texting him real quick and.
Yeah, see if he lost the connection. You can send him another invite or something.
I know I didn't, because normally when I'm doing this, like, minimized or underneath all of my homework. He lost us, or we lost him.
Yeah.
Hmm.
So it's wanting to ask, is those who die less, is the proportion of patients who have a heart attack and are admitted to the hospital on weekday who die less than the proportion of patients who have a heart attack and are admitted on the weekend.
Yeah, wouldn't that be the fourth bullet point for number 13?
Yeah, so P2 is wanting to know if that's the weekend, right?
Okay.
Hey, Josh.
Oh, he's back.
Are you back, Josh? Or maybe
Oh,
it's frozen.
you're frozen, Josh.
Josh. No.
Oh no.
They're having. Oh no. He said his internet died.
That's the worst. Like I've been there, done that.
We'll get him back into it when he gets here. Yeah, that makes sense. So it's wanting to know if those who die on the weekend, which is, yeah, is greater than those who on the weekday.
Hmm.
P1, that is 0.14.
P.141.
Yeah, that's what I mean, 0.141.
Okay, yep, that's what I got.
P2, 0.145.
Hmm. Find the z-score. Would that just be the negative 2.020?
What's that?
For the z-score, would that just be the negative 2.020?
Yeah, because that's the, I guess on here it shows a t statistic, but yeah, negative 2.020. Yep.
Okay.
Given
Um,
the z-score from the last question, what should you shade the left?
if it's
Let's see. I got it's right here. I remember. Oh yeah. So if P2 is greater, you shade the left tail.
okay, which ours would be greater, right?
Yeah, because I wrote
Ours
down
is
something.
less, but then the 2 is greater.
Yeah, 2 is greater. So it would be it says shade the left tail when 2 is greater. What is
Okay.
the p-value? So we have to change it to 2 is greater. I got 0.022.
0.022. Yep.
What is the decision for this test? We reject the null hypothesis because it was 0.05. So we can reject it.
Hey, you guys,
Yeah.
can you see me?
Hey, Josh. How's it
Hi.
going?
Oh,
I don't
Yeah,
know
I
why
can-
my internet just stopped working for a while, then it came back on.
hey, that's okay. I've had lots of dilemmas myself.
It happens.
Okay,
Right?
so you guys have probably moved on, but for question 12, the conditions are good, right? It's true.
Yeah, true.
Yes.
Yeah, that's what I got.
And then
And then we got the fourth bullet point for number 13.
Yes. Yeah, because it's asking if the P1 is less than. So for P1, did you get 0.141?
Yeah.
Exactly.
You're marvelous.
For the z-score, did you get negative 2.020?
Yep. Did you get 0.145, Josh, for 15?
Yeah, 0.141 for p hat 1, and for p hat 2 is 0.145.
Okay.
And then the z-score is negative 2.020.
Yep.
Mhm.
That's right. Then for a 17, we shade the left.
So for question 17, should we shade to the left or?
We chose the left.
Mhm. Oh, wait, is Josh frozen again? Or no?
No, Josh.
We're so close. Uh, Josh, speak. Hmm. Question 20, huh?
Yeah, question 20.
Okay,
So-
which of the following best summarizes the conclusion? So we do have sufficient evidence, right?
Yeah, so it's either B, C, or D. So, I mean, C or D. So, C says there's sufficient evidence for patients who have a heart attack and are admitted to the hospital on a weekday who died less than the proportion of patients who have a heart
Oh,
attack.
it would be the third, wouldn't it?
Yeah, because it's just saying that those on the weekday who died less.
Mhm.
The last one's just saying the same, so it'd have to be the third bullet point.
Mhm. Yeah.
How bad we did on this.
That
Josh, are you there? Josh,
Yeah, I'm here.
you here? Okay, we thought we lost you.
Sorry,
He's
it
back.
went out again.
We're not gonna lose you.
So for question 17, did you go to the left?
Yeah, we went to the left.
And then for the p-value, did you get 0.011?
Uh,
I got
0.0.
0.022.
That's what I got. 0.022.
But don't you have to divide it by 2 because it's single-tailed, not two-tailed? Or does the two-tailed thing only happen in SPSS?
It just happens in SPSS.
Oh, it's good to know.
Yeah, and we haven't used SPSS this entire unit.
I've mostly used the SPSS, not the
Oh, not the categorical thing?
not the Excel. No, it's an easy fix.
Once you get the hang of the categorical Excel thing, it's a lot easier, but at first it's like, okay, what am I supposed to do?
I did Excel and SPSS like back and forth just to get a hang of it, and I think Excel's a lot easier up front. You just plug in numbers and it gives you the answer.
Yeah, exactly.
But I don't know. I guess we'll try it, submit it, see what happens. Cross your fingers.
And then Josh, did you get 19 and 20?
Oh my gosh, I got a 50%. No, I'm just kidding.
Yes.
I hope not.
No. 19 and 21, so we missed a couple of them. So which questions are those?
Looks like I missed one.
You missed one, Josh?
Yeah,
I missed
I missed
Question
number
number
6.
oh, did I put the wrong one? Oh,
Oh,
The
what
point
did you say
estimator.
for 6, Josh?
I put 10. What did you put for it? Did you get it right?
Mm. Still trying to load.
oh, did you put 10, Josh?
Yeah.
Okay, that makes more sense. That makes a lot more sense because I did the upper bound and that doesn't make sense at all. So it should be 10.
Did you get number 6 right, Trevor? Okay.
So what other question did you miss, Josh? Josh?
I got number 6 wrong.
You got number 6 wrong?
Mm-hmm.
And you put 10?
I put 10, and it's
Oh.
wrong.
Okay, so I guess that's not the answer either. I don't know. I put negative 3 point negative.
It's supposed to be the 0.30 and not negative. Because I got number 6 wrong too.
So you got negative on that one?
Yeah, I put negative 3.
You think it's positive 308?
It might be.
Yeah, that question it's not up. You know, I don't. I don't know.
I don't know.
It's one of those ones where
I don't remember them ever talking about it.
it's one of they just
I know.
they're just tired of people getting 100, so they have to throw in something else.
They don't talk about a lot of stuff.
No, no, they don't.
You guys number 7.
7? What's that?
Number 6.
I missed number 6. Yeah.
Yeah, same here.
We all miss number 6. None of us know what the point estimator is.
Nope. Well, I guess we can guess. I don't know, positive 0.308, because I don't know what they're asking.
The only thing I can think of. I honestly don't know any other way you could figure that out. So now, did she email you the feedback, or is it just on your?
It's go to the project and go to design the study. You know what I'm saying?
Yeah.
Where you submit it. It's just in the back. It's just underneath that. It says feedback from professor, or whatever. And like all the questions, she has something on it. So we're gonna have to do a little bit of a revision for it.
So now, you guys know for sure or not if submit each of the things individually, or if it's just the collect the data and the evaluations we're supposed to submit?
I think we can submit them separately, but still have all the names on it still, just to have it. I don't know. But I guess on the bottom of the form, I guess we're supposed to sign something and didn't sign it.
Oh, were we just planning on doing regular M&Ms?
What that, Sarah? You kind of broke up a little bit.
Were we planning on doing regular M&Ms or like the peanut butter M&Ms?
I think regular because you have more variety. I don't know, colors. I guess you have to be more specific. I guess what she's wanting.
I think you should just go simple. I think we should just say the regular M&Ms.
Yeah.
And
Do
I
you have a
was
lot of
thinking
colors?
for our sample sizes, because we need to take a random sampling, instead of buying a big bag of M&Ms, we should buy those bags that have the fun size bags in them.
Yeah.
Right? So our sample size will be one individual fun size bag.
Oh,
You see what
yeah,
I'm saying?
that's, yeah.
So if we each buy one of those big bags, instead of the sample size being one bag and we count those out, we use the individual bags inside the fun size. Does that make sense?
Yeah, that's a good idea, bro.
Yeah, are you talking about just, and then it's got little packages inside? Is that what you're talking about,
Yes.
Josh?
Yes.
Yeah, that wouldn't be a bad idea at all. And then that way, that each bag would be one, representing one, right?
Yeah.
Yeah, that's not a bad idea.
And then yeah, so then it'd be a random sample instead of a stratified sample, right?
Yeah, see, I don't know about that. I never understood that.
Because the stratified is like so we go like every fifth M&M or every fourth, and that's how we. Because if we're checking for colors, that's not going to work out too well.
Oh, wait, was that stratified or was, I thought every nth, I thought that was a different one.
Oh, my bad. It is.
Once again, I never understood that.
Oh, my bad. Listen to me. Wait, let me look back on those notes. What is that?
Is it it's systematic that it's every nth one.
So sampling that, a simple random, best method for a random sample. Oh yeah, that would be systematic, my bad. So stratified is, so it's put in homogeneous groups, then a simple random is taken. Works well when one item differs from another, put in subgroups.
And isn't the simple random sample normally the computer generated?
Yeah, yeah, I think so. A simple random is the best method for obtaining a random sample. It can be obtained anytime. This complete list of items to be sampled. Each member of the subset has equal probability of being chosen. So I don't know how we do a simple random sample if we have M&Ms, you know.
Mm-hmm. Yeah, that's why I was kind of thinking either the stratified cluster one made the most sense for what we're doing.
And she questioned our stratified sample too.
Sorry, what?
Did she question? I think she question it, like doing our stratified
Sounded
sample.
like she questioned everything.
Yeah, like we're kind of stupid. I'm not speaking for you guys. I'm just speaking for me. I don't know what's going on. I mean, it's kind of hard when you don't know exactly what's going on in the class to know how to do a study.
Like, what exactly do you want?
They expect us to, you know, have all this, and well, I don't know.
Well, at least we can start collecting rather than, you know, doing like our like, no, you got to start all over.
Yeah.
Yeah, yeah, it's hard to say because it's like categorical or quantitative, because I mean it's almost like it's both, because we're looking for whichever color, right?
Yeah, I mean, is it bad to do a quantitative and a qualitative? I mean, a categorical? I mean, if we're looking for colors,
That would be categorical if we're saying like, oh, yellow has the most in samples.
but if we're looking for how many though, I guess that's also
No,
quantitative.
yeah, and then it's like, okay, well, would it be both then?
Yeah, no, is it? I don't know if it's a bad thing to have both.
Okay.
Yeah, and then her response for our question number 7 says refers to quantitative. So maybe it's quantitative.
So, in my comments below, okay, you need to say are the number of each color for the same equal. And so I guess, yeah, okay. All right, let's see if we can revise this.
Just resubmit it, or do we have to do something else?
Good question. Let's see, does she say anything here?
Oh, it looks like
What's that?
it looks like we would just
What is that, Sarah? Sorry, you cut out.
if you look above her feedback, it gives you a spot to upload.
Oh, right here. Okay. All right.
So yeah, in the her announcements, she says, "Go through my comments and make necessary adjustment. Resubmit to gain grade points back." And then she says you need to get approval, but how do we know if we got approved or not? Does it say anywhere in there that we got approved or not approved?
I think she'll tell us if we've been approved or not, which we haven't because we have a lot of stuff we need to fix.
Yeah, she'll probably
Okay.
email us or something.
To answer your question, sir, I think only one of us has to submit it.
Yeah, that's what I thought too, except for collect the data and the evaluation. Under the impression of Because did it show that you had submitted it, Josh?
I
Even
did
though-
submit it though.
Okay.
I submitted it. I submitted it as
We all
well.
submitted it because we didn't know any better.
Yeah.
Now the question is, how do we resubmit it?
I think there's an upload right here.
Yeah, like right above her feedback.
You need to put our names on the bottom though, right? She was saying something about that.
Yeah, I put my name on the bottom. You know, it says.
She said that. She said your name was on the bottom, but not mine and Sarah's.
Yeah, it says on question 18. It says each member of the group sign below that you will not collect data until your project has been approved in writing by your instructor in step 19.
Oh,
So
I
our
thought that
instructor,
was just. I thought that was just for if you had to get like a approval for the other.
that's something else. You have to go to the school.
Yeah.
So if we
So
can just
who's going to resubmit it then? Because I think only one of us has to resubmit it.
you want to resubmit it, Sarah?
So then just put our
Sure.
names on the bottom. Just make sure all three of our names are there.
Okay.
And then will you email me the corrected one? You guys went through and corrected it, right? Changed it?
Yeah, let's check to make sure we covered everything. Marian, she's like, did you mean to say are for the same M&M product equal?
What is it? Did you mean are the number of each colors for the same M&M product equal?
Yeah, because we just had, what did we have? Dominant color in the bag of M&Ms.
Okay. So I guess we have to be specific. Okay, so
We want to just change it to,
will there be out of all the colors in the bag of M&Ms, will there be a dominant color? I don't know. Is our kind of design question.
okay, out of all the colors in the bags of M&Ms.
Can we say regular M&Ms?
Yeah, say regular M&Ms.
Regular. I mean, she'll get the idea. Regular M&Ms. I mean, classic.
Regular M&Ms. One color that's more than the rest, or how would you word that?
I guess I was thinking it a little differently. I was thinking the idea of every color, how do I say this, will be represented equally. Like, let's say that there's 5 colors, there's 20 M&Ms, there'll be 5 of each color.
Yeah.
So each color will be equally represented in each bag of M&Ms.
That sounds good, Josh.
Right? Instead of us saying you're going to have 10 red but only 1 green, you should have 5 green, 5 red.
Yep.
And so I think she's right. It's quantitative, it's categorical because we're talking about the color, not necessarily the number.
Yeah. So yeah, that's right. That's it.
We're not saying that each bag will have a different amount. We're saying the colors will all be represented equally. At least that's how I was thinking of it.
Oh.
I like that. We want to make sure that.
So would you, yeah, with her question, are they for this product equal? Reword that so it's, or do you like that?
You could say, what is it?
If you put number in, you're going to have to do quantitative because the number is referring to that kind of study.
Oh, yeah, that's true.
So you could say, are the colors that
Is each color represented equally?
Yeah.
Okay. Tell me what you think of the colors of M&M of regular. Are the colors of regular M bags equally represented? Sense?
Yeah.
Yeah. And I guess also that kind of repeats the question to the study population. So just classic M&Ms, the big pack, where it contains a lot of little bags.
Yeah, what would you even call that? The big funds?
Yeah, let me see if I can pull it up something. M&M unpack. Boy, is it?
I guess I could just put, we'll be studying.
What's that? Oops, there it froze.
Yeah.
Back.
Hey, Sarah.
Okay. Okay.
So,
So for number 2, what do you think of this? We will be M&Ms from a lot of fun size packages.
yeah, you could say each of us will have one of those big, 30, 40 plus size fun packs. So it's like one big container with multiple fun pack sizes in it to give variety. And a large sample size. How would you word that? So,
Okay, so each of us will buy a big package of
the fun size M&M.
They're called the fun size.
fun size.
Yeah. It's a big bag of individual little bags.
Yeah, the big.
So each of us will buy a big of multiple fun size
M&Ms.
regular M&Ms from, oh, wait, or just that. Okay, each of us will buy multiple fun size regular M&Ms so that we have a variety.
Would we need it? Would we need it to buy it from like the same place, like Walmart, or or to?
You could do it at Walmart. You probably could just do it in any grocery store.
Any grocery store?
Maybe, I don't know.
You think we have to be specific about that, like where we're gonna buy it from?
Are you guys good with Walmart?
That's fine.
Where you buy everything, I guess. Yeah, Walmart works well for everybody. Probably.
Okay, I will put that in.
Hopefully they have it. I'm sure they should.
Yeah, I think I've seen them before, so.
Because hopefully it's not Christmas M&Ms, because that's green and red.
That could be bad.
Yeah. Well, it's either red or green. I don't know.
Well, we'll have to change our ANOVA.
Okay, so 3, experiment unit. Did you mean M&M bag? What do we? So.
So your fun size.
Yeah, it'll be the M&Ms, the color representation, in each of the fun size M&M packages. I'm guessing. So we have to be careful how we say the wording, or else it'll go to category to quantity.
I know. Yeah.
And shows.
Sure. So.
Oh, I'm not getting past this one.
Yeah. So for number 3, I just put our experimental unit will be the color representation in each of the fun size M&M packages.
That sounds good.
And then number 4, think about my comment on your research question. Right now we have our response variable will be the dominant color in each of our bags.
Yeah.
Maybe I should just put the color, just leave it at that. Our response variable will be the color. I guess I could put that again. Oh, wait. So our
experimental unit is 1 fun size M&M regular bag.
And then our response variable would be the color representation?
I don't know. What is the response variable?
I know.
The response variable is like your dependent variable.
So it's what changes from your variable.
Oh, scary. I'm just kidding. Let me put it better vocab. It depends on one of another. So our color, the colors, if there is a equality, it will depend upon the other color. So how do you say that?
Our response variable will be.
Yeah. So it's the variable is what you measure in the experiment and what is affected during this experiment. The dependent variable responds to the independent variable. So the independent in this case would be if there's a change, maybe. So,
Like what is the same or no? That would be controlled.
mm-hmm. Yeah.
Mm-hmm. But response would be like a color different. Well, yeah, then we wouldn't want to say like more than the rest, because then that would be quantitative.
I think that's what she's trying to tell us, is because didn't you originally say it was qualitative? And I think it's supposed to be. It's not categorical, but I think it is quantitative. Because we're trying to find out if the number of each color is the same. So we're looking at the number of, we're looking at the number of the color. I mean, color is important, but it's the number that we're really looking at.
Okay,
Right?
yeah. So maybe change
it would
that
be
to quantitative.
Yeah.
That makes it a lot easier.
Yeah. Because if it's categorical, it would be like if you ask random people what was their favorite color, right? Blue, green, the answers is a color. That's why it's categorical. Our answer is a number.
Yeah.
Okay.
Right? It's going to
That makes it
be.
easier.
Does that make more sense?
Yeah, definitely. Okay. So I changed that. So for our search question, do we still want to keep it, or
For question 4, you said?
for question 1, do we want to change our research question or just leave it how it is?
What does it say?
Are the colors of regular M&Ms in each of the bags equally represented? Yeah.
I think it's still asking quantitative there too, so
Okay. So that's good then.
yeah, because it's equal representation. That's a number.
Okay. So
Then question 4, what's the?
what is your response variable? Okay, so looking at the amount of the colors in each of the bags, would it be whichever one most or least amount, or?
We'll be looking for what is the most common color, or
I think the null hypothesis. Which way are we trying to prove? Are we trying to prove that they're all equal or they're not equal?
well, wouldn't the null say that they would be equal, but the alternative is going to say that they're not equal?
Yeah.
Is that what we want to get at?
So it's saying something like each color will have the same amount. And then the alternative hypothesis is one of the colors will have more than the others.
Yeah, one of the colors will differ. One of the colors means will differ from the others, I guess.
Okay, so for the null, right now we have the colors of the M&Ms will have equal means. And then the alternative is that at least one or more of the colors means will differ from the others.
Yeah, and did she say that was bad, or?
She just said, what do you mean by color will have equal mean? I think it was because we did the categorical instead of the quantitative. We changed it.
Yeah, it makes it easier. It's okay.
Yeah. Oh, and I guess we chose the ANOVA, and it even had the quantitative meaning of X.
Yeah, the quantitative, right?
Yep.
Yeah, quantitative. Three more. That makes, because that'll be a really easy test, because we each have 3 And we plug in those 3 samples, and boom, we got it.
Okay.
What do you think about this for the null hypothesis? The number of each M&M color will be equal.
Okay, one more time.
The number of each M&M color will be equal. Or what did you write?
So it just said will be all of the colors of the M&Ms will have equal means.
Or you could say, or I'm just an idea, or all the colors within the bag will be equally distributed. Like you might have 2 blues, 2 reds, 2 greens.
Oh, that could work too.
Because I don't know, because if you put equal, like all of those work great. What you said.
What was the last part you asked, Trevor?
What's that? I just say, yeah. I mean, all the colors in the M&M bag will be equally distributed in color. But you guys have a good ones too.
And then, now, Josh, you had mentioned on those same lines, right? That the regular. Yeah. I'm like, oh no, we lost. Can you repeat what it said for the null again?
What did you write for the null?
Right now I changed it. It will be all of the colors in the M&M's bags will be equally distributed in color.
Okay. That probably is easier to understand than mine. I just wrote, yeah, that's fine.
Now, is that at least more of the colors will differ from the others, right?
Yes.
Should I keep the means that the color from the others, or just take out the means?
What's that? Sorry?
No, you're good. For the alternative, I said it'll be that at least one or more of the colors means will differ from the others. Should I leave that?
You can say one of the colors will differ from. Let's see how to do it. We believe, yeah, one of the colors will differ from the other colors, I guess. There.
Okay. Do you think she'll get that, or should I just put like the?
Yeah, at least yeah, you can say at least one of the colors will differ from the others.
Okay, and just leave it at that then.
I think, yeah, what you had is pretty good. Oh boy.
That's 7, and then.
Then number 8 or 9?
I think it was 9. Yeah, she didn't have 8 on here.
What are your strata? Oh gosh, I don't know. How is your data collection approach? Okay, I think it's because we had a lot of categorical. So,
Oh, yeah.
so how many bags are you going to purchase? If you only identify the most dominant color from each bag, that means you collect one data record from a bag. I guess that makes sense too, because a strata is kind of you put everything in. But this is a tough one because I don't know which strata to do.
I wonder if I just need to add in the same size of bag, which has a lot of fun size packages in it.
Yeah, because I think we have multiple bags, which I don't think
That
she
idea is really hard to explain. You almost have to show them for someone to understand. Because you're buying a bag that contains many smaller bags.
Yeah, maybe try
Is
to be
what it is.
specific.
You're
on
buying
that
a
one.
bag of many small size.
I put that in. It has a lot of fun size packages inside it. I know we almost need to like attach a picture with it. This is what we're referring to.
Yeah, maybe you could.
That's actually not a bad idea. Let me.
Kind of get the idea because sometimes people think differently. Maybe they've never bought one of these fun packs in their lives. They're missing out.
Okay.
And she says, well, it's not question 11, it's actually question 10, but says, how do you know your data will be normally distributed? Well, because we have more than 30, we'll have more than 30 samples. That's how we know that
We should have, we'll have to see. We should have a lot because each big bag has a lot of fun size and we're each going to get a bag.
Yeah,
so think of however many bags are 1 times it by 3.
Yeah, or else just do like the greater than 30, and this is how we know because
I think we should have greater than 30 sample.
Yeah.
Yeah,
And
I definitely think so too. Where is my?
How do we know it's gonna be greater? Because God made it that way.
That's good.
I had a biology teacher. That's what he said all the time. He said, "I don't know the answer, but that's what God made it." Okay, that's wonderful.
Okay, so what else do we have there? Are you fixing the paper, whatever, and then you're going to resubmit it, Sarah?
Yeah, that's what I'm doing. As we're talking, I'm trying to.
Yeah, I guess just question 9 and 10, and just say if it's greater than 30, and then question 18 that everybody's name's out on that thing, that list right there.
And then when I email you guys, I'll just text you again and let you know I sent the email, and then I'll hear back. I'll wait to hear back from you before I resubmit it.
Okay.
Do you wanna put a picture on there? Or
I'm gonna find a little picture.
try to find a Google picture or something. All right. Cool.
Did you make sure you put your name, Sarah, and my name on the bottom?
I did that at the beginning, so I wouldn't forget.
And my name's on there too?
Yeah.
Okay. All right. I will get this video up on the discussion.
Okay.
Thanks,
Perfect.
Trevor.
Take
Okay,
care.
have a nice night, you guys.
See you on Thursday. Bye-bye.
Good Thursday.